Uma. Happy to have you at Salt.
Yeah.
So, this is a topic on something I'm extremely passionate about, the intersection of software and biology. I'd love to start with you, Jason. So, back in 2008, you and your team at MIT really predicted this technological renaissance in biotech. You saw the convergence of technologies, including CRISPR for gene editing, low cost genome sequencing, using software to literally program cells. And today, you're synthesizing things in the food industry, things in the farm industry, among others. And this Friday, guys, this Friday, Jason is taking his company public in what will be the largest biotech IPO of all time, raising $1.6 billion from Viking, Arc, and a number of others. Can you explain to the audience what programmable biology is and what the vision for Ginkgo is?
Yeah, happy to do it. So the core idea is that inside of every cell is digital code in the form of DNA, right? So it's A, T, C's, and G's. It's not zeros and ones like in a computer, but you can read that code with DNA sequencing, genomics, and you can write that code, and this is really important, with DNA synthesis, DNA printing, which literally means you go on a computer, you type A, T, C, G, 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 you hit print, and out of our labs in Boston or other companies like Twist Biosciences in San Francisco, a piece of DNA gets printed. And so if you can read and write code, and you have a machine that would run it, which is sort of how we think of a cell, you're programming. And so the idea behind Ginkgo, we realized this, AJ, like you mentioned back at MIT, because we were sort of engineers that came into biology later in life, computer scientists, mechanical engineers, and so on. And there's this realization that, well, if you look across all of life, the DNA is the same. And inside of every cell, the infrastructure is the same to read that code. And so why is it that you don't have the kind of horizontal platforms like we saw in computers? Like, where are the operating systems? Where's the Amazon Web Services, right? And the idea behind Ginkgo was, well, let's build that. What does the platform look like that makes it easier and faster to program cells year over year? What application? All the applications, right? Just like you wouldn't ask what application is Windows being written for, right? It's all of them. Which website is AWS for? It's all of them. The idea behind Ginkgo is, what engineered cell are you trying to produce? All of them, right? And our customers basically come to us, ask us to program them a cell, and we deliver it for them. And then we make money like Apple would in the App Store. We basically take a royalty, a value share on the value of that end app. And we'll talk about it today, but that can range, like AJ mentioned, from a $100 million joint venture with Bayer Crop Science to engineer microbes to produce fertilizer. We just announced a partnership that concluded with a company called Aldevron, which is one of the biggest mRNA vaccine manufacturers, where we optimize a cell to produce vaccinia capping enzyme, one of the supply chain components in mRNA vaccines, to Roche and antibiotics. We work with Altria's joint venture Kronos in cannabis.
Sure.
All of these things are actually cell programs. And so really excited to be here today to talk about how that technology is improving and share it with y'all.
Sure.
And yes, we are listing. Yeah, we're excited about it. What we're going to trade is DNA, which is used to be Genentech's old ticker before they got bought by Roche, which is for a bio nerd like me is like nirvana. So yeah, really excited about it on Friday.
That's awesome. So moving to you, Uma. So just to rattle off a few quick stats, I think 33% of the planet's non-ice landmass is used for agriculture. We're seeing 80 billion animals a year being slaughtered. And not only that, the demand for meat is expected to double by 2030. Can you explain what you're doing to change this, to solve this problem, and also what the essence of cultivated meat is?
Absolutely. AJ, it's great to be here back in New York. So cultivated meat is a field that's moving rapidly from science fiction into reality. And the idea behind this is you could cultivate meat directly from animal cells without having to raise an animal. So this has been a field in the waiting for the last several decades. You put a lot of stats on the table, but I want to restate some of them because they're so important. We right now have 7.5 billion people, and we eat about 75 to 80 billion animals every year. And the demand of meat is supposed to double by 2050. That means we'll need to figure out a way to grow 150 billion animals every year to feed 10 billion people. And these numbers are just mind-boggling because of the amount of meat that needs to be produced. And in doing so, we clearly have a clear impact on the environment, climate, animal welfare, and health. So the idea for cultivated meat that Upside Foods pioneered is in late 2015, we started the company saying, we want to grow meat from animal cells, so you don't have to raise billions of animals every year. And we started off in 2016, we released first a beef meatball. And that kind of just blew people's minds because we took a few cells from an adult cow. The cow doesn't need to be slaughtered, by the way, for this. And we grew it into a meatball and did a tasting. The Wall Street Journal wrote about it, and it just took off in people's minds. Because imagine if you can start producing meat across, any species, meat, poultry, seafood, and you start doing it with significantly less resources. Because, when you think about a beef cattle, it takes about 2 to 3 years to get to slaughter. For a cow, for a pig, it's about a year. For a chicken, it's 2 to 3 months. If you think about those lifespans for those animals, and we can say, we can do all of that in 2 to 3 weeks, independent of any species. It could be, beef, or it could be tuna. That opens up an enormous opportunity. And that's really what Upside Foods is pioneered. We've done beef in 2016. We've done chicken and duck in 2017. We are just in the process of building the first production facility that can show end-to-end production of meat in a clean environment, right from like the first cells. So we expect people to come and tour. We call it a slaughterless house. It's just obviously, it's in trend with all the things we want to see happening in the next 10, 20 years in the world. Reduced use of resources, reduced greenhouse gas emissions, improving awareness of where food's coming from. So I think we are tapping on into a trend just like you've seen in 2008 of programming biology. We think we can basically bring any edible species of meat, poultry, or seafood to the world.
Wow. So you guys have a lot of intersectionality in your work and in your companies. And one of the big mega trends in the food and ag tech industry in recent decades has been plant-based alternatives to meat products. Right? So you see Beyond, Impossible in the burger category. You see people like Oatly in the milk category. And this has been phenomenal. Many of these companies are now listed publicly. But there are two other paradigm shifts in the space we're also seeing, maybe in the earlier phase. One is precision fermentation.
Yep.
This is an area you do a ton of work on. You've got another joint venture in Motif, which is operating in the dairy industry.
Yep.
And let's perhaps start there, and then we'll go to Uma. And I'd love for you to compare and contrast the differences and distinctions and the nutritional profiles of these things like Impossible and Beyond relative to what you're working on. Start with Jason.
Yeah, so I think there's going to be kind of two generations here, and I can speak to the first one, and maybe speak to the second. So the first generation is exactly what you're saying. Things like the Impossible Burger, which, by the way, I know you're a vegetarian. I'm not a vegetarian. I grew up like having a cheeseburger every morning, every day for lunch, and so you bite into an Impossible Burger. It's pretty interesting. It bleeds. Right? That's a bit weird, right? There's not a lot of blood in plants. So how are they doing that? And what they've done is they've taken the gene for hemoglobin, which is the protein that makes blood red, and they take a yeast cell, like a brewer's yeast, and they program the genome, which is, what we're just talking about. You're essentially installing some new code in there. It's A, T, C's, and G's, but it's new code. And then you grow that yeast cell up almost in a brewery, except instead of beer coming out, hemoglobin comes out. And then you add that back into this veggie burger, and suddenly it smells right, tastes right. It's the Impossible Whopper at Burger King. First real innovation, as far as I'm concerned, in the burger industry, probably in 100 years or something, right? And so there are other animal proteins like hemoglobin. There are key proteins in milk that makes cheese stretchy, right? Have you ever had a vegan cheese? It's not a great experience, okay, right? That's because there's no casein in vegetables, okay? And so these types of proteins will be made by fermentation of microbes or yeast, and then added back into largely plant-based products. That's sort of the first generation. And one of our app developers, Motif, is doing exactly that at Ginkgo.
Yeah, I want to add on to that. So there's a couple of generations of food that are evolving very rapidly, and Beyond and Impossible and all plant-based categories have done a fantastic job improving awareness of why food has to come from a place where it can be scalable, sustainable. And I think they've done great in improving even the quality of taste of vegetarian, products. The burgers used to taste really terrible. And imagine with Beyond and Impossible, they've made them tastier. And they've done it through various combinations of, color, taste, flavors, and they've used recombinant proteins in the case of Impossible to make it have the little iron or metallic taste when you bite into a burger. And that's been fantastic. I think the evolution is going to be, continuously going to, like, what's the holy grail? When we think about the food that we've all fallen in love with for 10,000 years, meat's been the center of plate. And when you think about what's in the center of plate, it's a piece of steak or a piece of chicken breast, there's billions of cells in that. And cells are the building blocks of all food. And what we're trying to do is to say, look, let's take the cells, keep them intact, because the cells are already programmed with the DNA or the code of what they're supposed to do, and let the cells grow on their own way that nature has already programmed them to do. And we provide them with the nutrients, and the cells make the proteins, they make the fats, they make the little molecules that give you the taste and the texture and the aroma. So in our view, we think the palette is enormous. We don't think that one single protein can really, make up for, all the millions of molecules in a cell. So we're trying to harness the power of a cell and say, let's figure out a way to find the best quality cells for any species, and let's grow them outside the constraints of an animal. And that's step one. So you put a product out that has a taste and the texture, aroma features. And then the next step, this is where I get really excited as a cardiologist, is what if we start making the meat that we eat healthier? Can we start making it, better for patients that have risk of developing cardiovascular diseases or already have cardiovascular disease? Can we make this meat have characters that do not provoke inflammation in a human body? Or, think about athletes. They want high bioavailable dense protein. What if you make meat with higher protein? And think about patients with chronic kidney disease. They love to eat meat, but as a doc, I used to write the prescription, low protein, 2 gram sodium diet. Sure. Now, what if I can tell them you could eat meat, you could eat chicken, you can beef, but we can keep it low protein. Your kidneys don't have to bear the brunt of that demand. So it opens up the palate in a very different way. And that's really what I'm excited about this generation of, like, bringing meat to the table that maybe for the next 10,000 years could start evolving differently.
So to yes-and this a bit, there are 400,000 plant species that are edible to us humans, right? We're eating less than 5%, right? And that's agnostic of culture, whether you're here in the US, China, Europe, etc. And in the meat category, there's a few animals that we eat. It's really just cows, chickens, pigs, etc. Sort of a very narrow experiential band, right? And I'm curious for you, Uma, perhaps first, where do you see this going? What other unique combinations of food and protein do you expect to see on plates going forward in the future?
Yeah, it's a great question. I think Upside Foods is starting by launching chicken first. So we've already said Upside Chicken is going to hit the markets as soon as we get regulatory approval. We're working with the FDA and USDA to do that. And we picked chicken because chicken is universally loved in every culture, and it's very versatile to cook. And that's the reason for chicken. But we have a portfolio of products we're working on that includes beef and pork and seafood, crustaceans. But the thing that, as you talk about what's the next generation products, there is only a small number of animal species that are being eaten right now because it's easy to grow them in confined spaces. But what if we take those confines out, that we can literally take any edible cell from the meat, poultry, seafood species and start producing them in a clean environment? Now, game animals don't have to be at risk. The biodiversity doesn't have to be as much as risk, especially if you're hunting them down for meat. That opens up an incredible possibility. And think about seafood. There's enormous numbers of species we don't even know about, right? But we're just losing them en masse because of, whether it's deforestation in Amazon or, ocean, if you watch Seaspiracy, there's a pretty nice account of what's happening with the species. We think that if it's for food for humans, we can solve that problem.
Yeah.
In doing so, then you have a ripple effect, right? You don't have to plant, lots of crops in the Amazon. You don't have to, transportation of meat is a huge burden. Like if you start producing meat locally, that just changes everything. Local, regional, decreased transportation, not need to have the level of refrigeration and fear of salmonella or E. coli.
Yeah.
I think it opens up a lot of possibilities.
Sure.
So have you tried to do it? Have you tried to grow cells from like a panther or something? Right? Like just to see if you could grow them.
Yeah. Our engineering and scientific team are incredibly creative. They'd love to get their hands. I can tell you, we have someone who who was actually trying to figure out, can we bring the woolly mammoth back?
Okay, nice.
All right. So it goes back pretty far away. So it's not for a lack of
Mammoth
imagination,
steaks.
but
Yeah.
as a business, we need to make sure it's right front and center, putting products people want to eat right now.
Yeah. So I want to move to another really hot button issue, particularly here today with Dr. Scott Gottlieb here, and that's the pandemic, right? And Jason, you've been operating on the hyperdrive at Ginkgo. You're in the midst of the breakout. Last March, you were working in collaboration with not only the U.S. government, but also Moderna to help synthesize different aspects of the mRNA vaccine. I'd love your commentary on where things are today in regards to the pandemic from your perspective, and secondarily, how you guys at Ginkgo are thinking about prevention of future pandemics. How are you building sort of a societal immune system, if you will?
Yeah, this is a super good question. Yeah, I mean, I think one of the interesting things about the pandemic is we now have a lot more broad-based awareness of biology, right? Like everybody suddenly knows, my parents know what mRNA is and PCR tests and all these things, right? And so that's actually a good moment. I think, and not a great situation right now globally with the pandemic, but it's not like a situation that is leaving our minds tomorrow. Okay. And so I think it's actually, we're a little bit lucky in this happening before we got very good at programming biology. In other words, we're just at the beginning. We're just inflecting, right? It's kind of like semiconductors in the 50s or 60s or personal computers in the 80s with synthetic biology today, programming cells. And so we're getting to a chance to build like the kind of equivalent of cybersecurity before the internet, right? And that's what COVID offers us an opportunity to do. And so I think the big pillars to this are rapid vaccine manufacturing, rapid therapeutic development, and then surveillance testing. In other words, monitoring, kind of like you would with a weather satellite, so that you know what's going on.
Sure.
And we were lucky enough to be able to help. Obviously, I mentioned this project we did with Aldevron, one of the vaccine manufacturers, to optimize the production of one of these enzymes that's used in the mRNA vaccine manufacturing process at places like Moderna. The other area we've actually spent a lot of time in is in the surveillance testing category.
Sure.
So at this point, we're doing, I believe, more K-12 testing in the country than anybody right now, which is the country's done a good job giving a lot of money to states to say, hey, let's keep schools open by monitoring so that you could close a classroom, not a school.
Yeah.
Right. And that's the power of having this ability to see what's going on, to allow governors and other leaders so that to have less disruptive public health interventions, less quarantining, these sorts of things, while in the midst of an epidemic. And that, I think, is something we need as a country, just from a national security footing at a minimum, and certainly during COVID, so that our lives can be more normal. And so, yeah, we're happy to be participating in it. It is certainly a big problem, but I think you are seeing the country and the rest of the world kind of muscle up to build the technologies that hopefully then persist to make it way harder for us to get hit this hard again in the future.
Definitely. And to double click on this a bit, Jason, so there's been a number of talks this week about longevity, cellular reprogramming, the Yamanaka factors, among other things.
Sure.
You've got quite a bit going on in the cellular therapeutic space, in the biotech space, synthesizing small molecules, among other things. Can you touch a bit more on that?
Yeah, I mean, so the good thing about Ginkgo is we're not a product company. So I mentioned all these things we're doing. That vaccine capping enzyme, that's Aldevron's product. The work we're doing in antibiotics, that's Roche's product, right? And so there is a big opportunity. We just announced a partnership with Biogen, one of the big gene therapy companies, to work in AAVs back in the first quarter of earlier this year. That whole category of cell and gene therapy, I think particularly after the success of mRNA vaccines, you're going to see that category get substantially bigger in the future. You're getting manufacturing built out to make it cheaper. All these things are happening right now. So we expect that to be something that a lot of our customers come asking for in the next couple of years. Would be, hey, Ginkgo, could you program me, a more efficient gene therapy or cell therapy, TCRs, things like that, for sure. Yeah.
Yeah, and over to you, Uma. I mean, I remember, I think it was back in 2009, there was a breakout of H1N1, or the swine flu, right? There were 153,000 people killed over a 6-month period. That was, at the time, an unmitigated disaster. Today, you've got COVID-19, there's over 4.5 people dead in the last 14 months. Okay. Both of those instances emergent, one from a wet market in Wuhan, the other from a slaughterhouse, right? I'd love for you to touch on how what you're doing really affects food security, both here in the US and abroad.
Yeah, thank you for asking the question here. Look, this pandemic has touched us really closely, right? I lost my dad to COVID about 7 months ago.
Wow.
And I lost a first cousin to COVID about 9 months ago. And this was all before vaccines were available. And after vaccines were available, my dad's family members, my mom's family members, all got vaccinated. And they all survived after getting COVID. I mean, it's very clear how we innovated under pressure and got the vaccines out. So I lost my dear dad, who's been a big supporter. He's a veterinarian, by the way. I grew up with him, with cattle, sheep, everything around me. But nature has given us a clear mandate to adapt. And if we continue to raise animals in intense confined production facilities like we have now, it's just a place of intense concern. It's like I wouldn't want to use the word, but it's a ticking dash, right? So every effort should be made for us to, number one, walk back from that, what we've done to produce food. And that's where I hope cultivated meat can play a big role. You know, it's going to take a long time to transition away from the number of animals we're raising, and that is still needed to put high quality protein on the plates. Meat alternatives, plant-based, are doing a great job. But if we want to preserve the choice of eating delicious meat that is climate friendly, that is healthy, and doesn't increase the risks of pandemics, I think this is a really big opportunity for us. Even before COVID, we were talking about this all the time. But during the last 18 months, the amount of interest in the work we're doing just has gone up 10x. And there's dozens of companies across the world in nearly every meat-producing country, meat-consuming country that have been started. Governments have been giving grants on this. Undergrad and PhD research programs have been started. Lots of regulatory agencies are really active thinking through how could we get these products out to market. So I think we have a pretty big opportunity to adapt. This is the time to kind of pay attention to it.
Definitely. And Uma, you've done a lot of R&D across many different cell types. You seem to have settled on chicken as your beachhead product. When can we taste it? When will it be out in the world? And what does your product pipeline look like today?
Absolutely. So we announced Upside Chicken will be coming to the market. We're awaiting regulatory approval from the FDA and the USDA, and the agencies have been remarkable in producing a guidance on how we can regulate the cultivated meat industry by working with them. So we've announced our first partner, Dominique Crenn, who's one of 3 Michelin-star women chefs in the world, and she's in the Bay Area. So we plan to release our initial products through a collaboration with Dominique Crenn, Atelier Crenn Restaurants. But just to follow up right after, there's a number of restaurant partners and also smaller grocery chains that we're talking to, and we hope to be able to announce that. And we can't make enough at the moment, right? That's really why the first industrial scale production facility opening in the Bay Area is going to be, I think it's going to be, like a crown jewel for innovation. But based on that, we expect to build much larger scale commercial production facilities in the US and also outside the US that could make 10 to 20 to 50 million pounds of meat every year.
Wow, it's very exciting.
On the portfolio of products, chicken will be our first one, but like I've said, we're working on beef and pork, seafood, and crustaceans. We want to be able to release them directly as an Upside brand because we also see this as an incredible brand building opportunity, a platform that can bring, the foods we love to the plate. So if I say what's our ultimate vision and goal, we want to be the most desirable brand of choice for meat lovers across the world in 10 years from now.
Fascinating. And as the last question, we'll go to you, Jason.
Sure.
So really, this programmable biology megatrend is just getting started. And I like to think about it myself as sort of evolution going from natural selection to intelligent direction. Right? We're now able to shapeshift and program biology at will. Where does this go in another 10 years, in another 20 years, another 50 years, if you wouldn't mind?
Yeah. So what I think is cool about it is it's going to touch a whole bunch of different industries. So the way I get it in my head is I think about computers, right? That was a programmable technology. You put in different code, it does new things, it gets better every year. What industries did it disrupt, right? Media, finance, telecom, advertising, all the information-based industries. right? Well, why is that? Well, a computer is a programmable machine, but fundamentally it moves information around. It moves bits, zeros and ones. Well, a cell is programmable. You put in new code. I swear to God, it does new things. Incredible. It literally runs on digital code. But it doesn't move information around. It moves atoms around. So if you think of the industries that are going to get disrupted in the next 10 to 20, 50 years, it's all the physical goods industries. It's building materials, it's electronics, it's food, it's all the stuff. All the things that, by the way, you know what computers didn't disrupt? Hamburgers, right? You know, these industries have been left alone for the last 50 years of innovation, and they're all biotech industries. They just don't realize it yet.
Fascinating. And with that, we've got an IPO coming out this Friday. Keep an eye out for that at DNA, and hopefully we'll be tasting your chicken soon.
Absolutely.
Thanks, guys.
Thank you.